Go.
Good morning, ladies and gentlemen. It's time for refraction. Refraction, light bends when going through a surface. Yes, it does.
Yep.
This line here is going to represent the boundary between air and plastic.
Yeah.
And that's what it looks like. And then we've got our normal here.
It's perpendicular to the surface.
Yes. And so when we have an incident light ray coming in, light bends.
Yeah.
Right? And it's either gonna bend away from or toward our normal. We're gonna get more into that today. So it comes in, we've got a different change.
And then
of
it's
medium.
refracted as it comes out.
Yes, thank you. And then it's refracted, that's the word we need to use. It bends, but we call it refracted. And when we're measuring the angles here, again, we are always measuring from the normal, and here measuring from the normal.
So notice all the information that's here. When you draw, this is called a ray model diagram where you're using light rays. And notice how we have everything labeled. You're going to be making diagrams or you're going to label everything too.
There's a lot of stuff. I mean, labeling the different mediums,
Yeah.
right? Describing the rays as incident and refracted,
Yeah.
labeling, identifying and labeling the angles, identifying the normal, right? There's
Yeah.
a lot of components here.
Yeah.
But manageable.
Yeah.
Okay, so now we flip-flop. Now we're going from plastic into air, and you can see how light bends differently.
Yeah.
Right? We've got a little bit more bigger angle here than we did before. Okay.
Yeah,
As
but
a
everything's
refracted
labeled.
angle.
We got the angle of incidence for the incident ray measured from normal and the angle of refraction for the refracted ray measured from normal.
Yeah, it's all there. Okay. So in a moment here, we're gonna do a lab.
We're going to do a lab over here using a trapezoidal block, and we're going to shine light into it.
And what's gonna happen is light is gonna bend like this.
Yeah.
Okay, now take a look at it, stare at it. Incident ray coming in, perpendicular, and we have light that's being refracted and bent.
Yeah.
Okay, now notice, now this becomes incident ray, new normal, and light is bent again.
Yeah, you know what occurs to me is the board blank behind this.
Sort of.
Now let's erase it and show them something.
Can't even remember what this is from. Oh, I remember. It was from our review video.
Okay, so now what you want to do, how can you tell where the light, you want to dot right on here.
Oh, okay. Oh yeah, how are we gonna keep track of what's happening in our lab here? So we're gonna make a dot right there. We're gonna trace this,
Yeah.
and then we're gonna create a normal.
Yeah.
And then we're gonna shine a light in, and we're gonna put a dot right
And
there.
then we want another dot up at the other end.
Okay. Okay, and then
we need a dot where it comes out.
okay, we're gonna put a dot here, and then over here.
Yeah, and the idea is that when the light goes out, you've got these dots that you can connect.
Connect the dots.
This to this, this to this, and you can see where the light went.
Yes, yes, yes. Okay, so that sort of brings us to our next slide. Next slide said, oh, sorry, this slide says, how can we show where the rays were after we turned the light off? And, ow.
We just showed them that.
We just showed you, and we're gonna do that, okay?
Yep.
Is it time? No, not yet. Okay, what's our next one here? Oh, we just did that. This was supposed to be the next slide. We were supposed to keep our dots.
Well,
That's
you,
it.
I
That's
think it's in the same place.
I just erased
Oh,
it.
you right.
Okay. Anyway. Okay. So what we're going to be doing in our lab is accurately measuring and recording the angle, the incident ray angle, and then the refracted angle for both the front and the back surfaces
Yeah.
of this block that's shaped just like the trapezoidal thing you saw before. Okay. And ultimately, we're going to have something that looks like this.
And so there's 4 angles that we're going to measure. And there's going to be some difficulties with getting a protractor on these, but we'll talk about how you get around that difficulty in a minute.
Mm-hmm. And the last thing I'm going to say before we head off to our lab is, if light didn't bend, it would keep going straight after passing through a surface.
Yeah, so over here in this little diagram we've got here, the incident ray to the surface, if it didn't bend, would just keep going straight.
Mm-hmm. But that's not what happens. So,
Nope.
In fact, light bends. So let's go ahead and do this. I think we're ready. All right, so it says light gets bent. Oh, that's what that last slide is for. It says light. Anyways, okay. Light gets bent. Okay, so refraction on a plane parallel plate. Okay, so here is our lovely trapezoid, and so I'm just gonna go ahead and trace this, right?
It's a good idea.
Okay, let me just make sure it's in a good spot here. Okay, right there, boy. Can that look good?
Well, yeah, you can always move the light box later.
Oh, that's true. Okay. So I'm just gonna go ahead and trace this guy, and then I can take it off.
Yep.
And there it is. Okay. Now.
What's the next thing?
The next thing, so place the trapezoidal block on a sheet of paper and trace its outline. Draw a line normal to the parallel surface as shown in the sketch. Okay, so in order to draw something normal, oh, actually it will work. Well, no, let me go ahead and extend this line
You're
a
gonna
bit.
have to extend that line a little
Yeah.
bit.
Okay, so there we go. All right, I'm gonna go this way. Okay, so if I wanna do, so notice how I'm gonna line up my vertex here. And this has to be lined up with 90. That tells me I'm doing the right thing there.
Yeah.
And then 0 is right there, okay?
Well, go ahead and just draw a dotted line
Draw it
normal.
right there, okay. Boop, 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 boop. Oop, that's gonna be too far over, huh?
Now keep going.
Yeah, but that doesn't come
It's
out.
okay.
Yeah?
The more the normal, the better.
Okay, well, it's coming out this side.
That's fine.
All right, okay. All right, so from here, let's see, it says draw a line, normal, we did that. Place the experimental lamp on the normal, so that the beam of light shines over the normal, striking the block where the normal intersects. Okay, so.
So put the block back on the outline. And what you want to do is move this over here so it's along the normal.
You see how it's like right on the edge there? Is that okay?
Yeah. And what happens is the light goes straight.
Mm-hmm. Light goes straight through. Let's get it right on the normal there. Bada boom. Okay, straight through. Yes?
It doesn't bend.
Okay, now so we've done that. We've placed it on the light on the normal beam. Observe and describe the path the light follows. So it just goes straight through, right? No
Yeah,
bending there.
No bending through the surface when it goes along the normal.
Okay. Now it says move the experimental lamp to an angle off the normal with the beam of striking, of light striking the block where the normal intersects.
So you want to put the trapezoidal block back on the outline on the trace,
It's on there.
and then come in at a steeper more than that.
Let's go. Oh yeah, right there. Okay.
All right.
Really good. Okay, so we placed it on there. Mark a point on the incident beam. Okay, so I'm gonna just go ahead and do right there. Okay.
Yeah.
And then mark the point on the ray where it emerged. Wait,
Did I just move that block?
oh, you did a little bit.
Okay, now there's a lot of stuff going on here. This is a reflected ray right
yeah.
here.
Reflected.
And this ray right here that's going straight is actually going underneath the block. So it's going underneath
So
the block
that one
on the
right
paper.
there?
Yeah, that's on
Okay,
the paper.
ignore.
And then that one is the one that's the refracted ray.
Okay, so make a point on the incident. Mark the point where the ray emerges from the block, and point on the beam after it left the block.
Yes.
So right here.
Yep. And then you might want to use this
That's a
out
good
here.
idea. That is a good idea. Okay, and you know what? I'll do 2 right there, so that way we can see a couple of them.
So now we've got dots so that when we turn the lights off, we can tell where it went.
Okay. All right, so I'm gonna go ahead and turn this off. Oops, wrong way. Okay. Remove the block and trace the path of the beam. Okay, so now I'm just gonna connect the dots, right?
That's right.
Okay, so we know that this and this right there.
They make it a long line.
Oh, that's a really good point. Uh-oh. There's tape underneath the table right there. There we go. Like, why is it catching on?
Okay, you don't need this.
Oh, okay. That's right. Oh yeah, what am I doing?
Yeah.
No, you don't. I don't need that one. just into that spot right there.
Now, where's the dot where it came out?
Okay, right here.
Okay, so now connect
That
these
tape
two.
right there. You feel that tape right there? And there's for my it's my phone. It's where this goes at. It's
Yeah.
messing it up. Okay, so now we're gonna connect this dot with this dot right there, like that.
Yep. And then the
Okay.
ray that comes out of the block.
Okay, and this one we are gonna make long. Okay, so I'm making it look good. A little bit of discrepancy there. I'm gonna go for the long one. Okay. Okay, there we go. All right, so what's next?
Well, I would put an arrowhead right there.
Like this?
Yeah, to show that it's
Like that? We're
coming in, and then an arrowhead down here.
Okay. Okay, so remove the block, trace the path of the beam into, through and out of the block on the paper. Measure the angles from normal, incident, and refracted at each surface and record them on paper. Okay, so let's do this. So we measure from the normal.
Yeah.
I'm gonna go this way. Okay. And you know what? I'm gonna have to extend this line a little bit longer here.
Well, let's measure this one first.
That one first? Okay.
That'll be the angle of incidence.
Okay, so that's gonna be, wait, we gotta put it,
Our normal isn't long enough.
yeah. Well, let me go ahead and make this both a little longer here. Okay, so we wanna measure from here to here, right?
Yep, the angle of incidence.
Okay,
so what you
so-
want to do is spin that around.
Right here, like this, right?
Nope.
No, like this
Put
way?
Yep.
That's what I thought. Okay, so again, this makes it a little longer here. It's been a while since I used a protractor. Jesus Christ. Okay, so is that my middle part right there too?
Now, what you want is the crosshairs. It's not the
here to
surface. See the crosshairs right there?
Oh, I see.
That's what you want in the apex.
Oh, I see it right there, huh?
Yeah.
Right there. So Mr. Boykin says it's that crosshair right there.
And then you want 0 on either end on the normal.
Okay, right there. And then you got to make sure this lines up with that.
And how many degrees away from the normal are we?
Okay, so that's 10, 20, 30, 40, 45, 46.
Call it 46 degrees.
Yeah, okay.
Well, just
Where-
mark it on
yeah.
the paper.
I'm like, wait, where do we write this? Okay, so this is our angle of incidence, and it equals 46 degrees.
Okay.
Okay.
You know
All
what?
right.
Let's draw a new normal right here.
Oh, yeah.
And let's measure this angle of refraction.
Okay, so let me go ahead and extend this out a bit here then. All right, so we need a new normal here. Good right there. I have a feeling we're gonna need to make that longer, but that's okay. All right, so that's our new normal,
Now
and
let's
so
measure
now,
this angle right
you
here.
wanna do this one right? Okay. So we'll go here. Can you see it? Am I blocking?
No, you're fine.
I'm good here. Okay, it looks like my normal here is a little bit off. You see that? Because this is lined up. That's lined up.
Well,
Does that look all
measure
right?
your normal again.
Yeah. So my normal.
So put the baseline on this line. So
Yeah.
put this like this. And confirm that your normal's in the right
Oh, I
spot.
see, I see. Yeah, it's 90 right there.
All right, then such is life.
Yeah, okay. All right, so here we go. So I'm gonna go ahead and measure this guy. Okay, and
Like about 45 degrees or something.
yeah, 45. 46, right there. Okay, so this is gonna be our angle of refraction
Yeah, coming out of the block.
and 46 degrees, bada boom.
Now the
Okay.
hard ones. Now we got to measure this
Yeah.
guy and that guy. So this
Yeah.
line in the middle, you're going to have to use a ruler to extend it.
Yeah. Mr. Boykin has the experience with this.
I have done this a few times.
Good morning, teachers. Please stand for the pledge to our flag. I pledge allegiance to the flag.
See,
of
what
the
we're
United
trying to
States
do
of
is get
America,
something that looks
and
like
to the
this.
republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Amen.
Okay. All right, so we're trying to go for this angle right here, right? Okay, that's
Yes,
gonna be our
ma'am.
refract angle. Okay, so let's go ahead and line this up on there. Boom. Okay, so I'm looking at this line right here. You
Yes,
see that?
ma'am.
Okay, so 10, 20, 25, 26, 27, 28, it looks like.
28 degrees is the angle of refraction through the front surface, going from air into the plastic.
Okay, that's our angle of refraction right there. And now we want to figure out what this angle right here is going to be.
Yes, ma'am.
Okay. So I'm going to go this way right here. That way, right? That's right, yeah. Okay, go down the line over there. And then we have 20, 25, 26, 27, 28.5. 28.5 angle of, this is our new angle of incidence right here,
That's
right?
a new angle of incidence on the back.
Okay, I'm gonna call it, should I call it 28.5?
Whatever you measured.
That's what I got. The other ones are all 28.0,
All right,
right?
that went very well. Now
Not
what are we
bad.
supposed to do?
Okay, so it says, what happens to the beam as it passes from the air into the block?
Which, in other words, the question is, which way does it bend?
Okay, so here's our, here is our incident ray coming in, right here, right? And here's our normal, and as it goes into, normally it would just follow the straight line path, right?
It's
If
not
it wasn't
going
bending. But instead it bends towards the normal. Y'all see that? Okay, so what happens, the beam of air, it bends toward the normal. I'm gonna go ahead and write that down.
Can't hurt.
Okay, what happens to the beam as it passes from the block into the air? Okay, so now here's my new incident ray, right? And if it was gonna go straight out, which it doesn't, it would just look like that. Instead, it bends away from the normal.
Away from it.
Okay, so it bends away.
Okay, we're not going to answer this last question. You're going to answer this for it, but take a look at the data we've got with the angles. And then the question is,
What is the relation between the ray incident to the block and the ray emerged from the block? So that's this one right here
what's the relationship between that?
and this one right here.
I think you can do this.
You guys got it. Okay.
All right. I think it's it.
That was is that it?